this. So to integrate this function, we are going to use integration by parts. Okay.
Right.
So for integration by parts, we are supposed to have two functions, u and v. So since here we see only one function, so we are going to multiply this by 1. Arctan x times 1 dx. So now which of these should I take u and which of these should I take as v prime? So we have arctan x and we have 1.
V prime should be 1, U should be arctan.
Okay. V prime is 1 and this is u. Alright, so u is arctan x. So that means u prime becomes...
The derivative of arctan, isn't it c? No, wait, that's tan. The derivative of tan inverse, I only know tan is secant x tan x. Is it secant x squared?
No.
No, okay. I don't know.
You know this. Derivative of arctan is 1 over 1 plus...
Oh my god, 1 over 1 plus x squared.
Yes.
Wait, why did I forget that? How is that? Okay, I knew that.
Yes, I know you knew that.
Oh well. Okay.
Never mind. Okay.
Darn it.
Alright, so this is this, and then we have v prime is 1, so v...
And then v is x.
Is x. So let's use our favorite, beloved integration by parts. We have
u times v minus integral v prime u.
So u times v is this, times vx, so I'm writing x here, minus integral u prime times v. So times x, so I'm writing x here, and this is dx. Okay. So this thing is outside of the integration. Now we have this thing. So how are we going to deal with this one? Come on, this one, wait. You can do it.
Oh, sorry, I didn't see it because your mouse kind of froze, so I was like, wait, what is she pointing?
Okay.
So is it the one that's red? What do I do?
Yeah. So now we have to solve this one.
So you have the integral of x over 1 plus x squared. So in that case, that's basically saying that's the integral of arctan, right?
But we also have this x.
Oh, we have the x. Wait, I know how to do this. I know. Oh, wait, you do integration by parts again.
Integration by parts again. So, okay.
Well,
that actually, I haven't done it. I haven't solved this integration by using by parts. There is one.
Oh, wait, I feel like there's a simpler way. I'm trying to think though. I feel like I know. Okay, wait. Integration of x over 1 plus x. We talked about this, right?
Yes. This one I don't think we've talked about this, but this is something that I think you must have learned in your previous classes. Think about substitution. Can we do any substitution?
Substitution, the ones we learned, use substitution, trig substitution. I guess in this case, oh wait, you can do use substitution because you have x and 1. I mean, you can you could say u is equal to 1 plus x squared.
Yeah, so we will do the substitution. 1 plus x squared equals u. Now let me tell you how let me tell you this trick. So whenever you in an integral, if you ever see a function and you also see its derivative, right? Then it will always help to substitute this function as u. If you substitute this function as u, then the derivative of that function times dx will become du, right? So this times dx will become du. Now over here, this 1 plus x square is my function, and if I take integration of 1 plus x square, I get 2x, right? So
no, yeah. You told me if you have the specific integer or otherwise, and its derivative in that function, then you need to use u substitution to cancel it out.
yeah, that was the case for this type of integral, this one, when you have e to the power x, and inside the parentheses you have f of x plus derivative of f of x. That was this case that we discussed, but you also have this case when inside the integral, in the denominator you have f of x, and in the numerator you have its derivative times dx. So what happens in this case is, if we substitute fx as u, then its derivative f of f prime x times dx becomes du. Right? So then this integral will transform into du over u. Okay? So this is something that we identify here. So I see that derivative of 1 plus x square is going to be 2x, then dx equals du. Now we don't have exactly 2x in the numerator. We just have x. But we can manage this 2. We can divide the equation by 2. So we get x dx equals du over 2. Okay? And then I think we are done. So this is x arctan x minus this integral now becomes du over 2. So I'm going to write 1 over 2 outside the integral symbol, and we get du over u, which is basically ln x minus 1 over 2 ln x.
Wait, quick question.
Yeah.
Wait, how did we get du over 2 exactly?
From here, I divided, this is 2 times x dx. So if you divide this entire equation by 2.
Wait, why 2?
Because we need to find out the value of x dx. So this is like solving 2x equals, let's say, 9. So how will you solve this? You will divide the entire equation by 2, right?
Yeah, I get that. It's just I'm a little confused about the u substitution part. Like, I understand u substitution, but in this case, like, I don't really understand, like, the steps.
Which one? Which step? Tell me, I'll explain.
Like, from, like, when you started talking about, like, 1 plus x squared equals u, 2x dx equals du, like, that part.
This part, okay. So tell me, what will be the integration of 1 plus x squared?
Integration?
Sorry, I mean differentiation.
Oh, differentiation? 2x.
2x, yes. That's what we are doing. So 2x dx equals du. Is this step clear?
Okay. Yes.
Yes? Okay.
Yes.
Now, the thing is, in my integral, in the numerator, I have x dx. Right? So I need to find out the value of x dx. Right? So that I can see my 1 plus x square is u. I need to basically transform this entire integral in terms of u. So 1 plus x square is u, which is this. And what do I do about this x dx? So x dx I will get from here. The only problem is this 2 is multiplied with this x dx. So in order to get rid of that, I divide this by 2 on both the sides. Right? So
because you're trying to get x?
I'm trying to get x dx. So I just need to eliminate this 2. So then in the next step I get x dx equals du over 2. And that's what I have substituted here.
Is this always the case? The formula is always f prime of x over f of x dx equals du over u?
Yes, if you have this type of integral where f of x is in the denominator and its derivative it's in the numerator, so this will always happen. So if you substitute your f of x as u and then its derivative times dx becomes du, so you can see that over here this derivative of fx times dx, this is nothing but then du. Right? And then this will be ln u. And then we can put the value of u back. So this becomes ln of fx plus c.
Oh, okay.
Okay. So let's come back here. Okay, this is not ln x, this is ln u. And in the next step we will put the value.
Wait, one part.
Yeah.
Sorry again. Where did the 1/2 come from? Oh, is it the du over u and then you move the 1/2? Okay, out.
Yeah. Yeah. Okay. So now we'll put the value of u back. So x arctan x minus 1/2 ln u was 1 plus x squared.
Yeah.
Plus c. So this is the final answer.
Got it.
And then I don't know if you're taking some objective exam, you might see this final answer in different forms. They might write this as this x arctan x minus ln 1 plus x squared and square root. Because this, you know this property? If you have.
I've seen it before. I think in general, though, these kinds of problems won't be given objective because he wants to see your work.
Yeah, so then you'll get all the marks at this step. Okay, so do you want to note this down or shall we?
Yeah, I did.
You have done it?
Yeah.
Okay. So let's move to the next